Welcome back to PLC Programming from Scratch. This is Section 9, and we're going to be exploring the concept of HMI. HMI is something that you'll hear a lot in automation and in PLC programming, and what that stands for is Human-Machine Interface. It's a generic term that gets thrown around a lot and almost always in reference to a panel used to display graphics and accept user inputs. But HMI as a concept comes in a lot of different shapes and sizes. As a concept, anything that sends information out of a system and takes information from the user into the system is considered HMI. If you're sitting at a computer right now, your speakers and your screen are sending information out to you. Your mouse and your keyboard are allowing you to put information into it. If you're on your iPad, your touch screen serves as both. It's showing you images and it's accepting your touch inputs to tell it where to go, what to open, and what to close. It has a speaker that's giving you sound, audio information. So all of this is HMI. But when you're talking about PLCs and you hear somebody talk about the HMI, they're usually talking about one of two things. Either they're talking about a dedicated panel which runs a specific program designed to interact with the PLC, or they're talking about a screen program on a computer which serves the same purpose. And the reason an HMI is important for a PLC program is because, like we discussed in the last section, a lot of times you want to add a level of configurability above and beyond what's programmed from factory. We want an operator to be able to look at a screen or a set of screens and watch the process and monitor the values in the system. We also want him to be able to control the system, to turn the system on and off, to have HOA control over devices without having to go out to the device and touch a physical button, thus putting himself in harm's way. We want the operator to be able to establish set points and control alarms and acknowledge events, and all of that happens at the HMI. So the HMI is a huge part of a system. It's a critical and oftentimes necessary part of the system, and it's one that comes in a lot of different forms and requires a lot of consideration on the part of the programmer. So over the next few lectures, we're going to explore a few different types of HMI, and we're going to get a lot deeper into factory talk, which is one of the solutions available by Alan Bradley to develop screens for computers and HMIs. So stick around. This isn't going to be nearly as technical and hard to follow as program logic or alarm logic. So consider this your break. This is your chance to see the simpler, easier side of PLC programming. It's hugely important, but it's nothing complicated at all. So I'll see you in the next lecture. Okay, so we're going to get into a few HMI alternatives, a few ways that we can allow the user or the operator to interface with our system aside from just the traditional screen. We already have an idea of what an HMI is. It displays system values from our PLC in a graphical form or as a chart or as a value, something that allows the operator to see his process, and it allows him to send information into the PLC to establish set points, to change times and speeds and temperatures and various parameters of the process. However, the mechanism to do that can come in a lot of shapes and sizes. We have the traditional screen like this that we're used to seeing, that we all want to learn how to program, and it's actually very simple to do that. However, a lot of those dedicated screens are $4,000, $5,000, $6,000 a piece. So it's not exactly an unimportant price to pay. look at this Micrologix 1400 PLC, which we've been working with programming throughout this course. And do you see the LCD on the front of the unit with the up, down, left, right, escape, and OK buttons? That display can actually be programmed from within RSLogix 500 and used as an HMI. So it actually has its own HMI built in. Maybe it's somewhat of a crude HMI, but with that little screen and a little bit of program, you can do everything you need to with an HMI. Now consider this. A little 2x16 LCD display costs maybe $10, and 4 microswitch push buttons cost maybe 20 cents a piece. And this can be turned into an HMI with a little bit of programming and a little bit of wiring. But an HMI can be as cheap or as expensive as you want it to be. So I just wanted to put that in your mind, that not every project needs a $4,000 10-inch screen to govern the processes and allow the operator interface. Chances are the operator's probably not even going to touch the screen unless he absolutely has to. If the operator is going to be standing in front of the screen several hours a day, then yes, I understand the need for a large, comfortable, ergonomic display. But if your operator is going to be touching the system once every month to read a value or change a set point, let's not get carried away. Give them a cheaper HMI, cut the cost down on the project, win the bid. Okay, time to get off my soapbox. I'll see you in the next lecture. We're going to get down and dirty with these HMIs. See you then. Alright, now that we have a little bit better understanding what an HMI is, we're going to take a look at one example of an HMI, a few screens from a project I did in the past, and we're going to look under the hood of Factory Talk, get a behind the scenes view of what's going on, how the information is coming and going, and exactly what makes an HMI tick. Here we're looking at what an operator would see on a small 6-inch panel built into an enclosure on one water treatment system. This main menu offers 6 navigational buttons, including this alarms button on the top right. Clicking any one of these takes you to a different page of the menu, which we're going to look at here in a second. And down below you see some counts of regeneration cycles which have been run, and this is something that is only visible after you click an invisible button here and hold it for 20 seconds. So these aren't something that the customer ever sees, these regen counts. These are something only used for service personnel. So there are a lot of ways to build things into your HMIs that the operators might not even see or that are only used for engineers, but we'll get to that a little bit later on in this section. The overview screen of this project shows 3 vessels or tanks which are used for treating water. Each one of them has these red things covering the front, which are actually valves, and the color red indicates that they're closed. When they open, they turn green. You see this receiver tank to the left. That blue level actually rises and falls based on the actual water level of the tank. Here on the bottom we have various displays showing inlet pressure, outlet pressure, pressure difference between the inlet and the outlet. In this project we use that differential to determine when these vessels are dirty and need to be backwashed. We have a well pump, we have a receiver pump, and we even show a time remaining on the current backwash cycle, and this indication only appears when the backwash is actually running. So this is a pretty smart HMI. We see these manual tags which also turn into automatic whenever the vessels are in automatic control or manual control. We have these labels below that say backwash and fast rinse. Those actually alternate through 5 different stages of backwash depending on if the vessel is in a backwash state and which state it's in. If it's not backwashing and those vessels are in normal operation, these labels disappear altogether. Clicking on any one of those vessels brings you to a separate page with a hidden button that gives the operator specific control of each one of those valves to force it on, force it off, or to leave it in automatic mode. So even though it's not called HOA, this is HOA control. We also have navigation on the bottom, which takes us either to filter A or filter B, this obviously being filter C. There's a setup menu which brings the operator into all of the more specific configurations such as alarm set points, times, temperatures, things like that. We also see here on the bottom that we have log in, log out, and this box on the bottom with all of the S's tells who is logged in once this HMI is actually online and running. And this login and log out is used to protect certain functionality from unauthorized personnel. So that's something that we'll also get to a little bit later in this section when we're talking about permissions. And here's something that should look pretty familiar. For our backwash valve, which is labeled BV117 in this project, here's a basic handoff auto control for that valve, along with this green status indicator which toggles between off, auto, and hand. And this is a pretty standard alarm screen for a panel view HMI. This shows a history of what alarms have occurred and give familiar options to silence alarms and reset alarms, and we've talked about both of those in the alarms section of this course. This screen also gives the operator the option to clear the history and a navigation button to return to the main screen. So those are several screens of the HMI that we're going to be looking at. And now we're in the FactoryTalk View Studio HMI development environment, and we have open the actual HMI that we were just looking at. And now we're going to take a closer look at how information flows in and out of an HMI and how it's basically laid out inside of an HMI development environment. And in a later lecture in this section, we're going to actually be creating a small HMI so you can see the process of creating an HMI. The first thing in almost every HMI program, and that's Allen Bradley, Automation Direct, Maple Systems, or almost any other HMI development environment, is tags. The term tag refers to each and every data being read from a PLC or written to a PLC. As an example, let's look at a few tags within this project. We're looking inside of a folder here labeled Setup, and we have several tags. I'm going to go ahead and expand this menu out so you can see them. And we have one tag name here called Setup/Backwash Time. Now, backwash time as a description, and this is all contained in the HMI project, says that is the backwash time set point. So this is a set point that we're allowing the operator to configure, and that's going to determine how long our backwash cycle lasts. When we look up here through the tag setup parameters, aside from the name, we see that we at one time had to define this as an analog tag. Analog versus digital. We remember the difference that analog is something other than 1 and 0. This is larger numbers. We've set the description here, and it's allowing us to change that description if we want. We've set a minimum and maximum range in this HMI project of 0 to 100. So even though the PLC integer location can hold a much larger number, we don't want the operator putting in anything greater than 100. So we're limiting his options in the HMI so that if he tries to enter 200 or 1,000, it's going to kick back and say that there's an error, and the HMI won't write that information to the PLC. For data type, we have unsigned integer, and you see we have several options of exactly what type of data that this can be. In this case, if we look down in address, we see that this is stored to the shortcut micro, and this has an address of N7:4. And N7:4 should sound very familiar. It should sound a lot like a PLC address, and that's because this is writing to a Micrologix PLC, just like we've been programming in previous sections. And this is writing to an integer address N7:4. We also see under data source that we have type, device, or memory, and that's because we can actually read or write information from the HMI memory, not just an external device. But in this case, we're looking at tags from our actual PLC. So this is addressed to a device. And aside from our first tag, backwash time, in this list, you see we not only have analog, but we also have some digital tags. So let's go ahead and click into one of our digitals. This one is regen on DP-PB, and that is regen on differential pressure push button. And what this is a push button on the HMI. It allows the operator to determine whether a regeneration will occur on high differential pressure or not. So that's turning regen on DP as a function on or off. That might not make a lot of sense to you at this point. That's okay. We're not really talking about the process and operation of a water treatment system as much as we are the functionality of an HMI. So bear with me if maybe that description of the push button we're looking at doesn't make the most sense. Here we can see an example of type digital. And you remember under our analog type we had this minimum and maximum and scale and offset. These things don't pertain to digital because our maximum of a digital is always 1 and our minimum is always 0. We remember that was the whole idea of what digital is. So we don't need those options here. All we need to know is this a device tag or a local memory tag? And of course this is our device. Micro, which I'm going to show you where that micro comes from in just a moment. And here we have an address of B3:0/3. And I know that sounds familiar because that is a bit within our PLC. So each and every point of information, every integer, every float, every bit that we want to use in our HMI, whether we're reading that bit or writing that bit, or integer or float, we have to define it as a tag. And the reason is whenever we're referring to those things throughout the HMI development process, the HMI needs to know where to get that information or where to put that information into or out of a PLC. So where does this micro come from? Well, if we look in our navigation pane on the left, and we come down here to RS Links Enterprise, Communication Setup, we get this largely vacant window with device shortcuts in the top left and one single entry micro. What this allows us to do is add several different devices and to map each and every one of them to a different device on our industrial network. So if you remember in the RS Logix 500 environment, we have an RS Links window that pops up and shows us our network and shows us any available PLCs that we can connect to, download to, upload from, and go online with. Likewise, we have the same type of interface built into FactoryTalk, and this allows us to create these device shortcuts and associate them with a specific PLC. Right now we don't have any PLCs connected to this environment, but if we did, they would appear over here on the right, and we could assign 2 different PLCs to this single device shortcut, one for design time and one for actual runtime. So in this project, we don't have anything assigned for design time, but for runtime, we do have a PLC defined. And the difference between the two is design time is for when the programmer is sitting at his desk, creating logic, testing it, making sure everything communicates properly, and referring to tags on a non-operational system. Runtime is whenever the HMI is actually online with the PLC in its final configuration and ready to run in a real-world scenario. So anytime we see a tag referring to micro, we know that that means it's looking for this specific PLC, and then it's going into that PLC for its memory address of B303 or N72 or etc. So now that we know basically how data is referenced from our HMI to our PLC, let's jump into some of the displays or screens and see how the controls use those tags. So first, let's look at a screen that controls one of our filters. Here we have a screen that we already looked at. We saw a filter C valve control screen earlier. This is a filter A valve control screen. Other than the filter they control, these screens were exactly the same. And down here we see days until BW, which is backwash. This gives the operator a countdown of how many days are left in their operating cycle before this filter will automatically backwash itself based on time. And we see these 3 pound signs out to the right. These pound signs are a data point inside of our PLC, which is a running countdown of days. And when we open this tag up, we see that built into the text displayed on the screen, we also have this entry right here, and that looks a little intimidating, but when we actually double click it, we see what it really is. It's just a tag to filter1 \days until, and we know that we can look at that in our tags library, and that'll break down even further into a micro reference into our PLC and a specific integer location of N7 or N something else. And here we see that this integer is constricted to having only 3 digits, 0 decimal places, which obviously makes sense because it's an integer. And this fill left means if we have extra spaces that aren't used out of our 3 digits, then we will either fill those with zeros, spaces, or with nothing. So that's maybe a little technical at this point, but I'll go ahead and explain it since I mentioned it. We're giving this data point on our screen 3 digits, XXX. Well, suppose our actual value is only 1. Do we show a 1? Do we show space 1? Or do we show 001? In this case, we want it to look more natural, and we want it to resize itself automatically based on the number of digits in our value. So we went ahead and filled it with none. So what this display does then is says days until backwash, space, and then it references the tag filter1 days until, which will be a simple 1 or 2 or 5 or 10, and it'll say we have that many days left until a backwash. So next, let's look at one of these displays. This is called a multi-state indicator. We see that this has 3 different states, and those states can be increased all the way up to 2,000. I can't imagine having 2,000 different states for an indicator. That would take forever to set up. This one only has 3, and typically the ones that you build when you're programming will probably only have 2 to 5. And you see we have some configuration for the appearance of this display. We won't get into the specifics of all of that. We see that we have the states defined. Each one is a value of 0, a value of 2, a value of 1, or an error value, which is for any value that isn't specifically defined with a state. And for each one, we have some customization of what the colors will look like, what the caption will be, the size of font. And this last tab shows us connections. And connections points to a tag. In this case, device status backslash 011A underscore force underscore status. Now if we want to look at exactly what this device status 011A force status is pointing to in our PLC, we can click on tag and go into our device status folder. Let's expand this out so we can see the name 011A force status. Right click and edit HMI tag, and it shows us right down here that we're looking into our MicroLogix shortcut that we set up on our communications, and we're looking for the integer location N34:21. So if we want to see what this value is doing and how it's calculating inside of the PLC, we know exactly where to go when we open up our PLC program in RSLogix. So back to our display, we see we have several other things going on, several other controls. I have a hidden button, which is this rectangle right here. And if I double click on that hidden button, I see that it's a go to display button, which takes the operator to the screen called 02 main graphic. So with this hidden button over our vessel, when this HMI program is running and the operator touches this vessel, it goes back to that overview screen which shows all three of the vessels side by side and the general status of the equipment. So let's move that out of the way, and we want to look at these valves for a second. So I right click on that valve, I'm going to animation color, and we have this interesting menu that pops up with a lot of different animation options, such as visibility, rotation, fill, and let's look at color because that's the one we're using here. You see as an expression we're tied directly to a tag, device status BV, which is ball valve 001A, A because this is on vessel A. And we have two different states here. We have state 0 and state 1, and a different fill color for each state. So if this tag brings us back a 1 from the PLC, then we're going to color this valve green. And if we pull a 0 from this tag in the PLC, then this valve is going to turn red. And that is what we're using to show the operator that this valve is either open or closed. It's either green or it's red. And that is basically how all of the displays and all of the inputs on an HMI screen are set up. And we're not going to go through every single instruction in this HMI development environment, but later on we will walk through setting a few of the more common controls up. And really, once you understand how to set up one or two of the controls in an HMI, the rest of them are pretty self-explanatory. They all have a simple behavior and they all associate with tags in our PLC. So once you can define a tag and once you can drop a control and put the tag into its reference, the rest is just a matter of creativity on the part of the programmer and deciding what controls to use and what information to work with. But that is the basic operation of an HMI, and we're going to get a little more in-depth in a couple of aspects of this in the following lectures. But for now, you should have a decent understanding of how truly simple an HMI really is. It's just tags defined to memory locations inside the PLC and simple controls laid out on a screen which reference those tags. There is usually no logic, no math, nothing else that a programmer has to worry about when developing an HMI other than making it look pretty and associating it to the correct tags. I'll see you next lecture. Well, let's look at creating our first simple HMI program. Now this course is generally a PLC programming course, not an HMI development course. So we are not going to get super in-depth into HMI development, but PLC programming without HMI development is really extremely limited. So for that reason, we at least want to go over the fundamentals of HMI development. We have in front of us a PLC program designed to control a blower, and it uses HOA control. So right away, at this point, you should be able to recognize the logic. We have rung 0 looking for 3 different push buttons from our HMI. So obviously we know we're going to have to program those 3 push buttons onto our screen. We have a hand, an off, and an auto push button. Each one has a one-shot, which then, for one scan and one scan only, moves a value to our status integer for our blower. That is 0 for off, 1 for hand, 2 for auto. Then when we come down to rung 1, this is where we're energizing our blower output bit, and this is not addressing an actual output but just a bit because we have our I/O set up properly in this program. We are looking at 2 different statuses to allow our blower to energize. We're looking at the blower to be in auto mode and to have this bit energized, which is a blower call from program logic, or for our blower to be in hand mode, in which case we don't require any other conditions. We're going to tell our blower to run. And if you don't understand what this blower call bit is, this is for automatic control of our blower. If we have a greater process, one that at times is going to automatically turn our blower on and off, this is the bit that will be energized somewhere else in the program to allow this blower to run, but only if it's in automatic mode. And the only other thing we have going on in this program is we associate our blower out bit, which we're energizing in rung 1, with an actual output, and this output is coming right off of the PLC itself. So our output is 0:0, but for the extent of this lecture, that's not really going to matter. You'll notice I have all of the logic in one program ladder, and that is not a best practice, but this is a very small program, and this is just for demo purposes for an HMI. So for that reason and simplicity's sake, I just threw it all into the main ladder, ladder 2. So let's start developing our HMI. I have Factory Talk View Studio, which is Alan Bradley's primary HMI development package. And we're going to come up here and click on the New Application button, and we're going to give it the name Blower Demo and click Create. So it takes a little bit because there are a lot of different things that go into an HMI project, but once this finally settles down, we'll start developing and creating a one-screen program, defining a few tags, and then in the end we're going to go ahead and run this HMI live with our PLC program to see it working. Okay, it looks like the program's settled down and we're ready to start developing. The first thing we're going to do is we're going to set up an OPC server connection to our emulator, RS Logix Emulate 500, which is running our PLC program. This is not a step that you always have to do, specifically not when you're running an actual PLC. But since we're running an emulator and Factory Talk doesn't speak directly to the emulator driver, we're going to have to use an OPC server, which is an option built into RS links for communication with other types of devices and HMIs. So we're going to come over here to our project, right click, add new server. We're going to get an OPC data server. We'll go ahead and call that blower, and we're going to browse, which will bring up the option for an RS Links OPC server, which is running on our computer, of course. We'll hit OK, and that will give us access to our tags within the blower program. So now let's go ahead and set up our display. We'll right click on displays and click new, and that brings us up this very plain window. We'll go ahead and stretch that out just so we have a little bit more working room, even though it doesn't change the actual size of our display at runtime. Right click somewhere in this window, and I'm going to take display settings, and I'm in the mood for a black screen today, so I'm going to go ahead and click the color black. I like high contrast. And what do we need? Well, we have an HOA controlled blower, which means we would like to see something that looks like a blower. We'd like to be able to see if that blower is running or not. We're also going to need our handoff and auto buttons, and it would be nice to have a status indicator telling us what mode our blower is actually in, whether it's in hand, off, or auto. So let's start creating. I'm going to go ahead and start by creating a momentary push button. So we have this blue button, and when we double click on it, here are all of our setup properties. We're going to go ahead and start with connections. So let's click on tag. Here we have our blower demo project, and this is our OPC server for the blower. And you'll see we have several other OPC options under there for other projects, but in this case we're just worried about blower. And we're going to look at offline tags in this blower program. And I know you're seeing a lot of tags in here which you don't remember being in the program. Those are things left over in the data table which aren't being used anymore. The blower program we're using actually is a copy of a larger program which I hacked everything else out of. But all of the descriptions are still in the data file, so that's why we're seeing them now. What we're looking for are blower buttons, and we have right here our blower auto PB, blower hand PB, and blower off PB. So we'll go ahead and start with our blower hand PB, and we have state 0 and state 1. State 0 is when this button is not being pressed. State 1 is when this button is being pressed. So let's start by defining state 0. A background color, we'll give it this lovely shade of gray, and we'll give it the caption hand. Let's apply that so we see what it looks like. Well, right away I see a problem that the word hand isn't very noticeable. So let's make it bold, and we'll also change that caption color to black, and we'll make it a 16-point font. We'll click OK, and that looks a lot better. And for our state 1, unless we want our button turning blue every time we press it, we'll take a darker gray. We'll also write the word hand in there, 16 point, and we won't make it bold. And we will leave the font white, so whenever you press the button, it'll change a little bit, it'll change colors, and that way the operator knows he actually pushed the button. So what a momentary push button is going to do is when the operator presses that button, it's going to write to this location, our blower hand PB value in our PLC. It's going to set it to 1, and then whenever the operator lets go of this button, it's going to return the value to 0, and that's exactly what we want it to do. And just like we have a hand button, we're going to want an off and auto button as well. So I'm going to go ahead and copy and paste this button, and I'm going to move it down here, and let's align it so it looks kind of nice. We're going to need an off and an auto, so I'll just go ahead and create 2 different copies at the same time. And let's put them both in alignment. So let's set the properties for the second button. First thing we'll do so we don't forget is reset the tag. Now we don't want this one set to the hand push button. This one's going to be set to the off push button. So we'll go back into our tags and take our blower off push button. And then for states, we're going to leave everything looking the same, only we're going to change our caption to off to distinguish this from our hand and auto push buttons. Hit apply and hit OK. And now let's go ahead and set up our third button. Same thing, we'll go to connections. This is going to be our auto button, so we'll take blower auto PB. Our states, we'll go ahead and change the label to auto as well. Hit apply, hit OK. And that easily we've set up our three buttons which will be controlling our blower. So the next thing we want to do is we want to know what mode we're actually in. Are we in hand, or are we in off, or are we in auto? So we'll go up here and we'll take this multi-state indicator and we'll put that right here. Double click on it to bring up the properties. First thing we have to do is set our number of states. So we already know hand, off, and auto, that's 3 states. We'll set that to 3. And then we need to set our states for 0, 1, and 2. Now let's look back to our program real quick to see how we had those states mapped. We know we're mapping to N711, and we have 0 is off, 1 is hand, and 2 is auto. And we're certainly going to want to make sure those match up with our HMI program. So 0 we're going to label as off. 1 was hand, so we're going to go ahead and set that as hand in our HMI. And by default, that leaves auto for state 2. And let's go ahead and put some more interesting colors in here. So for off, let's go ahead and set the background color to red. For hand, let's go ahead and set that color to yellow. For auto, we'll call it green. And then we're going to change our fonts. We're going to make that 16 point again and black, so it stands up real nicely. And we'll do that for our other 2 labels as well, hand and auto. And we get a very simple display. And let's go ahead and line it up with everything else just so it fits and looks neat and it doesn't look like something that a 2-year-old drew with his elbows. And now we want to display something that looks like a blower. We can use all kinds of different graphics and import them into this environment. However, FactoryTalk comes with several symbols and graphics already built in. So if we look at this libraries and symbols and images here in our project navigation pane, this has already a lot of things in it that are there by default when we start a new project. So I'm going to expand libraries, and unfortunately we don't have blowers up here, but we do have the next best thing, and that's pumps. And we're going to take a generic pump icon which can look a lot like a blower, and we're going to paste that into our project right here. Now that's a pretty small blower, so we're going to blow it up and make it a much bigger blower. Now that looks great, and we can get rid of our library of images. And now we want to be able to see if this blower is running or if this blower is not running. So we're going to use some color animations to do that. So I'm selecting what looks like just this fan. I'm going to right click on that and select animation, color, and we're going to go straight for the tags. And right here we have our blower tags. Let's look back to our PLC program and see what was the tag called that we were using to energize our blower. We had that labeled as simply blower. Remember, this description up top which says blower out bit, that's just for within the PLC program. But what you see in green is what's available elsewhere. So we're going to go ahead and refer to this blower bit, which is going to be energized anytime our blower is running, regardless of what mode it's in, whether it's in hand or auto. For the display on the blower, we're not trying to show hand off and auto, we're just trying to show it's either running or not. So we're going to refer to that blower bit. And now that we've defined that, we'll set a couple of states. And by default, you see factory sets 0 is red and 1 is green. Hit apply, hit close. And something I just realized we didn't do when we were setting up our multi-state indicator is we never defined the tag. So we need to go ahead and associate that with our blower mode. That way it's going to be able to read that 0, 1, or 2 and define the appropriate state. And I'm also going to bold up those displays just so they're a little bit more visible and a little more attractive when we look at them. There we go. And this program should be ready to run. So let's go ahead and save this display that we've created. We'll go ahead and call it main. And we'll close out of there. And now let's go ahead and test our application. So we go up to application and hit test application. It's going to create a runtime file, and then it's going to run that on our computer, even though this HMI project was actually developed for a standalone screen. Alright, and here is our simulated HMI. And if we look right now, our blower is red and it shows that it's in the off position, so it's not running. If we click auto, now it's in auto mode, but since we don't have process logic energizing the auto control bit, it still isn't running. Now if we put it into hand mode, now we see that blower turns green, which means it's actually running, and it shows that we're in hand control mode. So this is what our HMI program was supposed to do. And it is that simple to set up a basic HMI program. You define the tags, define the communication, drop in your controls, and it's as easy as 1, 2, 3. Obviously, a real HMI program for a live project will have a lot more controls, a lot more displays, a lot more graphics, maybe even some custom graphics and things like that. But really, it's all just more of the same. It's the same basic concepts multiplied several times over. If you can make a small HMI like this, making a larger one is only a matter of a little more creativity and a lot more time. The last thing that we want to look at within this HMI project is alarms and notifications. And I'm going to make a very short lecture of this just to show the basics of setting up an alarm inside of an HMI. Depending on the HMI you're using, of course, the alarm setup procedure is a little different, but it all comes down to a tag and some type of notification, and then the options to either silence the alarm or reset the alarm. Now in our program, we're still looking at our blower program, and that program does not have any alarms built into it, which is fine because all we're really looking at right now is setting up alarms, not the actual process of coding them into a PLC program. We've already covered that in a previous lecture. For now, I'm just going to show how to set up a bit within the HMI development environment as an alarm. So if we look over here at our Project Explorer pane on the left, we're going to scroll down to Alarm Setup and give that a double click. And that brings us up this alarm configuration window. And the first thing we have is the ability to select triggers. So we're going to add a trigger, which is a tag, and I'm just going to go ahead and use the blower tag, which tells us when our blower is running or when it's not running. Hit OK. And then I'm going to assign a message to the blower tag when it has a value of 1, and I'm going to give it a message, blower is running, exclamation mark. Obviously that's not something we would typically want to notify an operator of, but in this case that's what we're going to use as an example. And then under our advanced tab, we're not going to set this up right now, but just to show you, we have a silence optional connection, and we also have a reset optional connection. And here is where you would tag into your alarm silence and alarm reset bits, so that anytime you hit the alarm reset or alarm silence button in the program, it's going to go ahead and do the same thing in the PLC program. And that's what we want to happen. Back when we were talking about alarms and notifications, if you remember, alarm reset and alarm silence are what we use to handle notifications and alarms. So let's go ahead and hit OK. And now we're going to click our little running man, which is the same thing as going up to application and clicking test application. And after a couple of seconds, it's going to show us our HMI that we created in the last lecture. Only this time we're going to have an alarm every time we turn our blower on. Okay, so our HMI popped up, our blower is off, and if we put it into auto, we should get the status changed to auto, but since our blower doesn't come on, there is no alarm. But when we put it into hand, now we get a nice pop-up that tells us our blower is running, and we have the options to acknowledge or silence or clear alarms, or just to close that menu. And alarms are as simple as that. Generally, in an actual HMI project, you can have 20, 30, or hundreds of alarms, but they all set up the same, and depending on the HMI project you're using, setting up the tags might be a little different, setting up the messages might be a little different, but those same basic components, alarm reset and silence, tags, and messages, are pretty standard in all HMI packages. So if you know how to go about setting up an alarm, you might have to hunt it down if you're in something like Seymour or Maple Systems development environment, but the same things are going to be there, and they're going to perform the same functions on runtime. And alarms and HMIs are as simple as that. Alright, the very last thing we're going to look at, which is a pretty important part of HMI development, is security/permissions. There are times when you do not want everybody to be able to change everything on an HMI. Sometimes you want to reserve a screen only for more technical personnel than the simple operator. So in this lecture, we're going to look at setting up a security profile for our blower demo HMI project, and we're also going to test it all the way through. So the first thing we want to do is look at user management. When we look at our project navigator pane on the left, if we scroll all the way down here in the system folder, we find users and groups. And we're going to go ahead and start with a new user. So we're going to right click, new user, and the username will be Paul. And I'll go ahead and set a really difficult password of Paul, P-A-U-L. I'll confirm it, and I just created a new user. And now I need for that user to be a part of a group. So I'm going to right click under groups, select user group, and we'll call this group bosses. I'm going to go ahead and add a member, show users only, and that's going to be Paul. So I am now the only member of the group bosses. And that's really all we need to do under users, to add a person and to add a group that's going to be managed under a security profile. The next thing we want to do is come up here near the top of our Project Explorer, and we're going to go into Runtime Security. And here's where you set up different permissions for different groups of users. So you see we have security codes A through P, and down here we have a default user. So right now, anytime the HMI is open, there doesn't require a sign in or anything like that. It's just one user group, the default, and that person has all access to everything. Well, right now we're going to go ahead and disable security code A from the default account. So let's go ahead and accept that change, and then we're going to add another account, and we're going to call that the boss's account. And that one is going to have all the same permissions as the default, indicated by all these Y's under here. And it's also going to have access to security code A. So anything that we assign the security code A to, the default user will not be able to access, but anyone in the group bosses will be able to access. So let's go ahead and close this and save changes. And now we need something to use to demonstrate this security lockout. So we're going to go to displays, and we're going to create a new display, and we're going to make this a very simple display. We're just going to go ahead and put a text box here and put a very important message in that text box, which will let us know that we've made it to the page. I think that'll be an obvious confirmation. And we're going to need to get to this page and get back from this page. So I'm just going to put a return to display button down here. And we'll go ahead and make that a nice gray with the label return. So what that button is going to do is send us back to wherever we came from. So whatever page sent us here, if we click on this, it should send us right back. I'm just making it a little prettier. There we go. Now, I'm going to right click on this page and select display settings, and you see right here I have security code with an asterisk, which means it doesn't have a security code assigned to it, and I'm going to assign the A. So now this whole page is security code A. We're going to close it, save it, and we're going to save it as test page. Now let's go back into our main, and I've added a login and logout. I've also added this string display properties, which is associated with the system tag user. And other than that, these don't require any configuration whatsoever. If you go up to Objects and Advanced, you can drop a login, a logout, a password change, any of these things right from the menu. All you have to do is draw it on the screen and walk away. It's that simple to configure. And then we need a button that's going to take us into our page that we just created. So I'm going to use this Go to Display button here. We're going to set that up, and we're going to point it to the display we just created, which is Test Page. And we're going to go ahead and make this button pretty just like we did the other one. We're going to give it a caption of test. Let's make that bold, 16-point, black font. That looks great. And let's go ahead and test this. So we click on our running man after we save this, and we wait. And there's our open HMI. We can see that everything's online and working normally. We've got our little alarms built in and everything. And right now, it shows that we're logged in as the default user, which means really nobody's logged in. And when we try to go to the test page, we get this system-generated error message Very hard to read up here, but it says access is denied, so it's not letting us go in. Current logged in user does not have security access to test page. So we're going to click on login, then we're going to click into user, and the user is of course Paul. Hit enter. We're going to click on password. Our handy dandy password is also Paul. Hit enter. And then we're going to hit enter again from here, and we see that the logged in user changed to Paul. So now we should be able to go into our test page like a boss. And when we return, all we have to do is click log out. We're back to our default user, and we are locked out of our test page once again. So that is all there is to managing permissions. It's worth noting that in some HMI development programs, you can not only limit access to entire pages, but you can also limit access to specific controls. So you can have an entire page full of things that anybody can access, and just one button or 2 or 3 inputs that only a technician can use. That just depends on, again, what type of program you're using to create your HMI. But when it gets down to it, setting up who has access, logins, passwords, and associating those security codes with each different control or page is really the same. It's the same concept, just different implementations across different platforms. But as far as concepts go along the road to understanding PLC and HMI, that's a pretty easy one. Alright, you've made it to the end of HMIs, human-machine interfaces. And by this point, you should have a pretty clear understanding of what goes on behind the scenes of an HMI. When it comes to setting one of these things up, you might have to stop and check a help menu or look in a forum once or twice, but you really should have a good concept of what goes into developing a set of screens for a project. Beginning with tags, there's addressing them to the PLC, establishing communication, whether it's with an IP address or the name of a processor in RS links. That just depends on the platform. After that, setting up displays shouldn't be any problem. It's time consuming, and you'll want to experiment with the different controls available in your HMI. But you have multi-state indicators, you have push buttons, you have numeric displays, text displays, numeric entries, and these are things that you see across the board on almost all development environments. You have little lights and bulbs and meters and things like that. The animations are a lot of fun to play with, and different environments have different animations and visibility effects, and they all tie back to tags in the PLC. Speaking of tags, addressing those to different PLCs, understanding the idea of a B and an N and an F value, bits and integers and floats, by this point should certainly be no mystery. You should have a clear understanding of what those are and how to bring them into the HMI. Some HMIs, including the one that we used today, also have the option of limiting the operator input to within a certain range. That's very helpful in protecting the PLC program from erroneous entries. If you want a percentage input, it should be from 0 to 100. You don't want an operator to be able to come along and enter -6,000. Who knows what that's going to do to a running program? Other than that, setting up alarms in a PLC is the same as almost any control. You associate each alarm with a tag. You generally put a message in, and you're going to want to have 2 different controls for most HMIs to manage alarms. You're going to want to have, at a minimum, an alarm reset and an alarm silence button, and those are going to tie back to the actual management of the alarms and notification bits inside of the PLC. The last thing we covered in this section was management of permissions and runtime security in an HMI, and that is as simple as setting your security code to each individual control or each individual screen to which you want to limit access, and then setting up your user group, which can include as many different users or groups as you want, depending on how many different levels of access you need in your program. None of these concepts are going to really be mastered by watching videos. This is a great way to learn how these things work. This is a great introduction to these things. But in the end, what's going to make you a master and ready to go out and create programs and HMIs is to practice. And after you've developed a few sample programs, a few example HMIs, you've worked through some of the bugs and difficulties of establishing communication across different devices and HMIs, and almost no two setups are ever the same, then you're probably ready to start doing this for a living and to start getting paid for doing it. HMI development isn't what comes to mind when most people think of machine programming. The ladder logic, the bits and the floats are usually the things people think of, but almost any PLC project is going to have an HMI, and it's very rare that you're going to have two different people developing. So if you want to program the logic, you're really going to have to learn how to do the screens, how to set all of those controls up, and how to make it all work together. In the end, none of this stuff is hard. It's all pretty easy to learn. It's all pretty easy to master. It takes a little bit of study and a lot of practice. I'll see you in the next section.